Okay, so now I have loaded my data in, and I have also assigned Tmax to the first column of dummy, Tmin to the second column of dummy, and precipitation to the third column of dummy. And one caveat is that I've loaded this data in without infilling any missing data. What I will advise is that you try to identify where you have holes in your data. These are going to be places where you have NaNs. And the reason I suggested that you choose a station that has nearly complete data is that it's a pain in the ass to go back and try to infill missing data. And I'll refer you to a couple different places where you can actually infill data. One is the WestMap site that is detailed on the homework assignment itself. The other website you can actually get through is, do I have it actually open here? I will send it to you, but there's another website that gives you the data all at once. If you use the WestMap page, you have to pull data in month by month. Fortunately, you'll have chosen a station that doesn't have a ton of missing data, but just as a caveat, we're going to look at this. We're going to look at creating a climatology with some missing data. Okay, I'll show you a workaround to that. But what we can see here is that we've now have these three new variables, Tmax, Tmin, and precipitation. And this is for a station that, again, we loaded data starting in January, ending in December. That means that the length of that array should be divisible by 12. And we can look up here in your workspace, and I've loaded here an even 100 years worth of data. You should actually try to figure out how many years of data you've loaded. So in this case, you take that first number, divide it by 12, and in this case it's really obvious, 100 years of data. Okay, that 100 is going to be quite valuable, because what we're going to do is we're going to convert this one-dimensional array into a two-dimensional matrix such that we actually organize the months and years into a format that we can easily work with. Okay, so I'm going to create a new variable called tmax1, and what we're basically going to do is we are going to reshape this array, this one-dimensional array, into a two-dimensional matrix. Okay, so it's going to be, we're going to reshape, and what we're going to do is we're going to send in Tmax. Tmax again is 1200 by 1, or whatever your variable length is. We're going to reshape it into something that's 12 by 100. In this case, it's going to be 100. Probably for your case, it's going to be 50, 65, whatever the case may be. Okay. Once we can do that, you can put a semicolon around it, and you should see that you created a new variable that is 12 by 100. Okay. Let's do the same thing for precipitation while we're at it here. Okay. PPT1 equals reshape PPT 12 100, and we'll do the same thing for Tmin. Okay. We're going to do the same thing for each of these. So that's all in a nice format. All right. So we've done that now. One thing, when you create a climograph, you want to actually, there's two options. One is you can plot a time series. What we're going to do is create a monthly normals. We're going to create monthly normals. So we want to know what the average temperature is for January, average precipitation for January. Do the same thing for February and go all the way through the calendar year. What I'm going to do here is actually average maximum and minimum temperatures together to create the monthly average temperature, which is basically the monthly average maximum temperature plus the monthly average minimum temperature divided by 2. Okay, so I'm going to create a new variable called tmean. We'll call it tmean1 just to be consistent here. Tmean1, and it's actually equal to tmax1 divided by 2 plus tmin1 divided by 2. Okay, so it's really just the average of those two variables. Okay, and now we've created a new variable called tmean1. All right, now if you recall, these variables are all in standard units, so we're going to convert them over to degrees Celsius, and I can do this by calling my function that I created, mean 1 C equals convert F to C of T mean 1. Okay. And for precipitation, I didn't create a function, but what we can call it, we can call this PPT1 millimeters, and it's going to be equal to PPT1 times 25.4. That's just a conversion ratio. Okay, so note here we have PPT1 millimeters. It's 12 by 100. Okay, means all the Januaries are in that that first column. February's in the second column, etc., etc. Same thing for T-min or T-mean 1C. All right, and I want to just make a quick simple plot here first, and I can just do this by typing plot T-mean 1C. And when we do that, what you should notice right away is that you create basically a spaghetti plot. Okay, and on the x-axis here, we're looking at months. So 1, that's January to February. If we go here to 8, that would be August. Okay, and on the y-axis here, we have temperature in degrees Celsius. This is mean temperature in degrees Celsius. Okay, and you should all see something that looks like this. You'll see some variability, and that variability is part of climate. You'll see something in the middle here. This is the average. That's the climatological mean. Okay, that's what we're going to be plotting in our climagraphs. For fun, you can do the same thing for precipitation, PPT1 mm, and it should look quite a bit different, and it's going to very much depend on your station that you chose. So this station I chose here, which we'll find out what that is in a second, has a very ugly looking climatology for precipitation. It's kind of all over the place. All right, so let me show you how to use that climatology, the climograph function. What I've done is I've actually put that climograph function in my workspace. Okay, so I should see it under current folders. I should see the function climograph, like you can see here. And you can see how it works. You basically are going to send in temperature and precipitation. The extra pieces here are unnecessary, so just send in temperature and precipitation. Now, what I'm going to send in is the climatological average from 1981 to 2010. So you should know the first year that you entered in. You should know that number. In my case here, the last year I entered was 2011. I have 100 years of data, and what that means is that the first year I entered should have been 1912. All right. So you want to take the last 30 years, except you want to go from basically 1981 to 2000. And I want to have you create a new variable called tmin climo, and we're going to make it equal to the mean of basically tmean 1c over that 30-year time period. Because we have missing data here, I'm going to have you use a function called nan mean. This basically performs a mean, but it ignores those missing data. It ignores the missing data. Okay, if you just do a mean and you have missing data, you're going to get missing data. Don't do that. So use nan mean. Okay, and we are going to type in tmean 1c. Okay, and if you look at tmean 1c, you will see that it has it's 12 by 100. We want to average over those 30 years. Okay. So in my case, I want to average over years 70 to 99. It should be a 30-year time period. Okay, and the way that this function works is that you type nan mean, the variables you want to take an average over, and then the dimensions you want to average over. So I want to average over the years here because I want monthly normals. And so I type nan mean, my variable, and then I put comma 2 because I'm averaging over that second dimension, which is the years. Okay? And we'll see that that creates a new variable called tmean climo, 12 by 1. We want to do the exact same thing for precipitation, ppt climo. Okay, and the same thing here, ppt 1 millimeter. Okay, and we'll see that we have now nice variables 12 by 1, 12 by 1, Perfect. This is what we want to send into the climograph. Okay. I type CLF, which clears the previous figure that I had. You might want to try that sometimes. And I type climograph, T mean climo, PPT climo, cross my fingers, and what should appear on the screen is a climograph. Okay. And here we're looking at basically the 30-year average climate, what you expect for this station. And just to familiarize ourselves with these plots, the red line on the x-axis, of course, these are the months of the year, January through December. The red line shows the mean temperature in degrees Celsius. So this is the mean temperature, not the maximum or minimum. The green bars are showing the climatological average precipitation, how much precipitation is expected or the normal for a given month. Okay, and so we get a sense of when the rainy season is, when the dry season is, when it's warmer, when it's cooler. And you should all see your red line should all look something like this because you're all picking a point in the northern hemisphere, hopefully, unless you've done something severely wrong with your data. Your precipitation will be quite telling. If you look at the precipitation here, it's in millimeters. This location that I chose is extremely dry and extremely, extremely warm. The mean temperature here during the month of July is about 40, close to 40 degrees Celsius. And I have just so chosen Death Valley, California, which is the driest location and warmest location in the United States. So my climograph is a little bit on the extreme side. That's how you would go about creating that climograph, and you can do one for just 2011. How you would do this is you would go here, back to climograph, and you would type T mean 1C. Okay, so remember T mean 1C has your whole data. And what you want to do now is just send in the last year of data. Okay, we're not sending in the average over 30 years. We're just going to send in the last year of data. Okay, so T mean 1C, that's what we want, right? PPT 1mm, okay, that's what we want. We want to send in all 12 months, but just for the last year. I did that, but I forgot to clear the figure. So I'm going to clear the figure first. CLF. Okay. And you can hit up in MATLAB, and you can actually recall the last lines you've typed in. All right. Let's go take a look at our figure. Whew. This is what happened last year in Death Valley. Obviously, they didn't get much precipitation in the wintertime. They got some precipitation in August. That was the wettest month. However, again, this is like one day. Their rainfall over the course of the year is equivalent to maybe one day in the Olympics. So extremely dry, but quite variable. Okay? And so these are the two plots that you are looking to create. I will advise you to try to infill your data prior to creating these plots. It will save you time. Once you've actually created an infilled time series of data for your station, for the monthly data, you'll be using that data for the rest of your Adopt a Climate station. So this is a very critical step, and I'd like to help see you get through this step. This is the big leap that you have to take. And once you get over this, hopefully it won't all be downhill, but it just won't be as steep as an uphill.